Now let's see the summary of ATP synthesis by doing oxidation of one glucose molecule. Now during glycolysis, when glucose is converted into glucose 6-phosphate, in that process one ATP molecule is consumed. Okay, minus sign represent that one ATP molecule is being consumed when glucose is converted into glucose 6-phosphate. Now during glycolysis only, when fructose 6-phosphate is converted into fructose 1,6-bisphosphate, in this reaction also one ATP molecule is consumed. Now in glycolysis, when 2-glyceraldehyde 3-phosphate is converted into 2-glycerate 1,3-bisphosphate, then in that process 2 NADH molecules are being synthesized. Okay, 2 NADH molecules are synthesized when 2 molecules of glyceraldehyde 3-phosphate gets converted into 2 molecules of glycerate 1,3-bisphosphate during glycolysis. Now when this two molecules of glycerate 1,3-bisphosphate is converted into 2 molecules of glycerate 3-phosphate, then in this reaction 2 ATP molecules are produced. Okay, so this is the substrate level phosphorylation of glycolysis, which results in ATP formation. And when 2-phosphoenol pyruvate gets converted into 2 pyruvate molecules, then in this process also 2 ATP molecules are produced. So in this conversion 2 ATP, then in this conversion 2 ATP, total 4 ATP are produced by substrate level phosphorylation, and in these two conversions 1 ATP molecule is being consumed. So net ATP production by glycolysis is 2 ATP, and 2 NADH molecules are also produced in glycolysis during this conversion. Now let's consider mitochondrial reactions. Now during mitochondrial reactions, when 2 pyruvate molecules are converted into 2 acetyl coenzyme A, then in this reaction 2 NADH molecules are being synthesized. Okay, so 2 molecules of NADH we got in this reaction, and 2 molecules of NADH we got in this reaction when glyceraldehyde 3-phosphate got converted into glycerate 1,3-bisphosphate. Now let's consider citric acid cycle, because the acetyl coenzyme A produced here then goes into the citric acid cycle. So when 2 isocitrate molecules gives 2 molecules of alpha ketoglutarate, then in this reaction of citric acid cycle there is synthesis of 2 NADH molecules. After that, this 2 alpha ketoglutarate gives 2 molecules of succinyl coenzyme A, and in this reaction also there is generation of 2 NADH. So isocitrate 2 alpha ketoglutarate 2 succinyl coenzyme A yields in total 4 NADH molecules. After that, when this 2 succinyl coenzyme A gives 2 succinate, then in this reaction also 2 ATPs are produced. Okay, 2 ATP generation is there when 2 molecules of succinyl coenzyme A are converted into 2 molecules of succinate. And when these 2 succinate molecules give 2 fumarate molecules, then in this reaction 2 FADH2 are produced. Okay, succinate giving fumarate produces FADH2. And finally, when 2 malate molecules give 2 oxaloacetate molecules, then in that reaction also 2 NADH are being synthesized. So 2 NADH here, then 2 NADH here, and 2 NADH here. So total 6 NADH molecules are being synthesized in citric acid cycle, 2 ATP molecules are being synthesized in citric acid cycle, and 2 molecules of FADH2 are being synthesized in citric acid cycle. So when one glucose molecule is subjected to glycolysis, then mitochondrial reactions, and then citric acid cycle, then this one glucose molecule yields 10 NADH molecules, 2 FADH2 molecules, and 4 ATP. And as you note, 1 NADH molecules give 2.5 ATP. So 10 NADH molecules will give about 25 ATPs, and then this 1 FADH2 gives 1.5 ATPs. So you get 3 ATP here and you have 4 ATP. So 25 plus 4, 29 plus 3, 32. So in total, one glucose molecule will produce 32 ATPs. Okay, once this NADH and FADH2 goes into the electron transport chain, then they will be responsible for synthesizing ATPs. So this is how the calculation goes. Now one glucose molecule can either yield 30 ATPs or 32 ATPs, and this number depends upon the mechanism by which there is shuttling of NADH equivalents from the cytosol to mitochondrial matrix. Okay, how do you shuttle the NADH from cytosol into the mitochondrial matrix? On that mechanism, the number of total ATP molecule generation depends from one glucose molecule. It could be either 30 or it could be 32. Now, in case of prokaryotic organisms, the complete oxidation of one glucose molecule results in the generation of 32 ATPs. And why is that? Because no shuttle system is required for the transport of NADH. Okay, that is the reason why 32 ATPs are generated by doing complete oxidation of one glucose molecule. Now let's try to understand how 30 or 32 ATPs results by the complete oxidation of the glucose. Why it is 30 or 32? Let's try to understand that. Now, when glucose is converted into two pyruvate molecules, there is formation of 2 NADH. Okay, where the glycolysis gives 2 NADH molecules, and these 2 NADH molecules are in the cytosol. They are not in the matrix of mitochondria, whereas the NADH which are produced by the citric acid cycle is there in the matrix. So you don't need to transport the NADH from the cytosol into the matrix in case of citric acid cycle. But during glycolysis, you produce NADH in the cytosol, and the thing is that this NADH just cannot directly go into the matrix. It requires a shuttle system for that. And for that, you have either malate aspartate shuttle system or glycerol 3-phosphate shuttle system. If it goes via malate aspartate shuttle, then it goes in the form of 2 NADH molecules. Okay, you have to watch the shuttle system video that I made, then you will understand. If the malate aspartate shuttle system is acting, then the mitochondria will receive 2 NADH molecules. But if glycerol 3-phosphate shuttle system is acting on this 2 NADH molecules, then 2 FADH2 will be there in the mitochondrial matrix. Okay, the electrons will be transported in the form of FADH2 if glycerol 3-phosphate shuttle system is acting. And if a malate aspartate shuttle system is acting, then electrons will be transported in the form of NADH only. So the NADH, if comes in the form of NADH only, then 5 ATPs are produced and you have your 32 ATPs. But if the NADH is getting into the mitochondrial matrix in the form of FADH2, then the oxidation of FADH2 will produce 3 ATP and you will be having 30 ATPs in total. So the NADH which is produced by the glycolysis makes the difference of 32 or 30 ATP. If on that system malate aspartate shuttle system is acting, then 32 ATPs will be produced. But if on that NADH glycerol 3-phosphate shuttle system is acting, then 30 ATPs will be produced. Now the thing is that this malate aspartate shuttle will transport NADH only when the NADH is to NAD plus ratio is higher of cytosol as compared to the mitochondrial matrix. Okay, when in your cytosol the NADH is more as compared to the mitochondrial matrix, then only malate aspartate shuttle system will act. So if your cytosol is having more NADH as compared to the matrix of mitochondria, then 32 ATPs will be produced. But if the cytosol has low NADH as compared to the matrix of mitochondria, then malate aspartate shuttle system will not act. Glycerol 3-phosphate shuttle system will act, and it will transport the electron in the form of FADH2, which will result in the formation of 30 ATPs. So when in your cytosol the NADH is less as compared to mitochondrial matrix, then that will eventually result in the formation of 30 ATP molecules from the complete oxidation of one glucose. I hope you understood it. Thank you.